We have learned three main formulas about the sum of either consecutive integers or consecutive squares or consecutive cubes. I want to show you a real shortcut for finding formulas for consecutive sums of consecutive fourth powers, fifth powers, sixth powers, whatever it is you want. That only takes a few seconds. First of all, I'm going to put little exponents on these to see some sort of a pattern. So there's really a formula that I didn't put before here, which is 1 to the 0, 2 to the 0, 3 to the 0, plus n to the 0. Well, that's the same thing as just 1 plus 1 plus 1, so it just becomes n, or I'll write it 1n. Now this formula can be simplified or can be turned into like standard form by multiplying it out and getting it into the form 1/2 n squared plus 1/2 n. And this third formula, if I multiply this whole top thing out, which would be complicated, and divide everything by 6, I could get it into a form where it's like coefficient 1/3, in this case, n cubed plus 1/2 n squared plus 1/6 n. And even this thing, if I multiply it out and get it into the form where it's like a coefficient times n to the fourth, it'll be 1/4 n to the fourth plus 1/2 n to the third plus 1/4 n squared. We always go down to the n term, so I'll just say plus 0 n, because this one wouldn't have one. And there's going to be a way of using the coefficients from one of these formulas to find the coefficients for the next formula, and then use the coefficients from that formula to find the coefficients for the next formula, and so on. And I'll show you how this works. I'm going to create a triangle, and the triangle is going to have the number 1. That 1 comes from here. So the first row has the 1 in it. The second row is going to have two numbers in it, which are 1/2, 1/2. And the third row is going to have the numbers 1/3, 1/2, 1/6. I'll call this, row 1, row 2, row 3. Row 3 is the formula for sum of squares, but it is the third row of this thing. And I want to show you a tricky way, or a fast way, of getting the next row, and then any other row that you want. First observation is that every row has one more number than the row before. Another observation is that the sum of all the numbers in the row always equals 1. So 1/2 plus 1/2 is 1, and 1/3 plus 1/2 plus 1/6 equals 1. So if I know all but the last number, I can figure out the last number by subtracting from 1. Okay, here's how I get the fourth row. To get the fourth row, the only thing we need to know is the third row. There's a little formula for getting the numbers, and it works like this. To get the first number, we're going to multiply the number above it, so that's 1/3. That's the number above the number I'm trying to get. So you take that number and you multiply it by, and here's what you do. You take the row number and you subtract 1 from it, over that same row number plus 1, minus, and number is different. This number depends on what position I'm trying to get. In this case, I'm trying to get the first position, so it's minus 1. Otherwise, the formula is going to be the same for all the numbers in that row. When I simplify this, look what happens. I get 1/3 times 3 over 4 plus 1 is 5 minus 1 is 4, becomes 1/4. And 1/4 is the answer there. Now the only difference for getting the second element, well, for one, well, there's two differences. I'm going to use this number. So instead of 1/3, I'm going to multiply 1/2. You always multiply the number that's above the number you're trying to get. And instead of, I still have 4 minus 1 on the numerator of this fraction, but instead of 4 plus 1 minus 1, I'm going to do 4 plus 1 minus 2. So this is going to be a half now, and this other number is not going to be 3/4 anymore, but it's going to be 3/3, which becomes 1/2. Okay, to get the next number, I take the number that's above it, which is 1/6. I multiply it by 4 minus 1 over 4 plus 1 minus, in this case, 3, because it's the third number I'm looking for, which is 1/6 times 3/2, which becomes 1/4. And this last number, well, the last number you always get by doing 1 minus the sum of the numbers you have already. And in this case, it actually becomes 0. As you can see, 1/4, 1/2, 1/4, 0 are the coefficients of this. 1/4, 1/2, 1/4, 0. When you do this process for the fifth row, you would end up with, and this is for you to do, 1/5, 1/2, 1/3, 0. And then once you have a 0, you're always going to end up with a 0 underneath it. But the last element's not a 0. If you do 1 minus the sum of 1/5 plus 1/2 plus 1/3, you actually get negative 1/30. And this means that the sum of 1 to the 4th plus 2 to the 4th plus 3 to the 4th up to n to the 4th as a expanded polynomial will be 1/5 n to the 5th plus 1/2 n to the 4th plus 1/3 n squared plus 0n, sorry, that's to the third, plus 0n squared minus 1/30n. Now this expression here, maybe it can be turned into a nice thing that's factored that looks more like one of these equations. But I'm not sure what that becomes, but all I know is that this is the answer, and it does work. So that's the process for finding formulas. You can try to get the sixth row if you want as an added challenge.